Question number 1.9 on the board. A boat moves relative to water with a velocity which is n, which is 2 times less than the river flow velocity. At what angle to the stream direction must the boat move to minimize drifting? So let's say this is the river and this is the width of the river. Okay, so the river has its own velocity. Let's say it is VR, and the boat has some velocity. Now, let's say the velocity of the boat is in this direction, which is theta angle from this vertical. Now the total angle that we have to find is 90 plus theta, so we'll figure that out. Now it is given that VR, the velocity of the river flow, is n times VB, and n is 2, so VR is more than VB. Okay. Now let's suppose that the resultant vector will be in this direction. So obviously the boat will reach the other side of the river, other bank of the river at this point. Okay. So this is what we are calling the drift. So the question here is, at what angle theta should the boat be moving so that this drift is minimized? Okay. So let's look at that. Let us assume that the boat reaches the other bank in time t. Okay. So the net velocity in the x direction is what? VR minus VB sine theta. VR minus the component of VB in this direction. So this times the time will give you the drift x. Okay. Also, VB cos theta is responsible for the crossing of the river. So VB cos theta times t should be equal to the width of the river d. Okay. Now let's replace t by d divided by VB cos theta in equation 1. So then x becomes VR minus VB sine theta times d divided by VB cos theta. Okay, or we can simplify this to write d VR by VB sec theta minus tan theta. Now VR by VB is n, so this can further be written as d n sec theta minus tan theta. Okay, so to minimize x, we will do dx d theta as 0. So if we differentiate this with respect to theta, this becomes n sec theta tan theta, and tan theta's differentiation is sec square theta. So we equate this to 0. So we have sec theta n tan theta minus sec theta is equal to 0. Now sec theta cannot be 0, so n tan theta minus sec theta must be 0, so this is equal to sec theta. This is n sin theta by cos theta, and this is 1 by cos theta, or we can simply write sin theta is 1 by n. So theta is sine inverse 1 by n, or sine inverse half, which is 30 degree. So the boat has to travel at 120 degree, 30 degree plus 90 degree, which is 120 degree with respect to flow of river. Okay, so pretty simple. So that is our answer.